Hi everyone, welcome to today's webinar on using point clouds in Tekla structures. Now I'll run through how to do so in Tekla, how to use point clouds. I'll run through as well what point clouds are. So for you guys that don't know what point clouds are, some may be quite advanced in the area, and some might be quite new because this webinar is going to everyone. Now I'll also go through myself. My name's Jason Carpenter, and thank you for attending. So what I'll do is I'll run through what my experiences are, run through using point clouds in Tekla, and then also go into the depths of how to use that, and then also a Q&A session at the end. So myself, I'm a technical consultant through the Trimble Building Suite at Building Point, part of the Herger Group, and my previous experience entails civil and structural design and construction, PTs, concrete contracting, BIM systems coordinating, and in my current role, I look after anything to do with the hardware and software integrations, Trimble Connect, Trimble Mixed Reality, and Tekla structures, as well as customer development and implementation moving forward. So as I said, today's session, we'll run through Tekla structures overview, point clouds in Tekla structures, tools for point clouds in Tekla. So the tools, as you can see there on the right, there's a couple of new tools for Tekla 2020 and some Tekla support. So if you're going through any rough patches with the software and clouds, basically what we'll be able to do is go through 2 seconds. Can someone message me just to make sure they can hear me? Is that all right? Just got a couple of messages. Yeah, all good. Sweet. Thanks, guys. So moving forward, let's jump into the Tekla structures overview. So for those that don't know what Tekla is the leading steel detailing software package globally. So what this actually means is that we've got all of the components, so to speak, in regards to creating steel detailing and creating steel details, as well as precast details, reinforcement detailing, the whole lot. So if you're wanting to get up to the LOD 500, Tekla is the place to go. Not only does it keep the model super detailed, it actually keeps the model relatively small as well. So we're able to basically tackle those major projects and not have to worry about everyone upgrading their computer specs. We can run on decent computers. You still need something decent, but at the same time, you can still run a decent model on an okay computer. As I said, single tool for all types of materials and projects. So as you can see there on the right hand side, so this is the Museum of the Future in Dubai. Fully detailed, fabricated, automated fabrication side of things. Everything is done through Tekla structures. Trimble Connect was also a part of this in regards to collaboration out on site. And as you can see, it's quite complex. So design automation as well as detailing automation saved an absolute shitload of time. And I believe that if point clouds have been used on this, and I believe they would be, it'd be an amazing model to see what the new features of Tekla 2020 can entail for that. Open collaboration, so we can bring in models, and I'll show you that as well in regards to working with point clouds. Basically, we're going to bring in a point cloud and then work from that. So without further ado, I will jump onto Tekla, and just give me 2 seconds. I'll just bring it over onto this screen. So with Tekla, we've got this model view here. We're able to bring in reference models. We're also able to bring in point clouds. Now, when you're attaching a point cloud, we're bringing these in from any other format. So basically, it's a group of points that are imported into Tekla as one unit, and each of these points may or may not have color, depending on how they've been exported from, let's say, a TX6 or an X7 or a TX8, depending on what format and what program and what hardware that you guys have. So once once we're opening this situation up, we can actually minimize these. We'll go through those in a sec. But if we were to go to attach, we grab our own file here. We can bring in files such as ASCII files, E57s, LAS, LAS, PTS, PTX, pottery, and Trimble scan format, so TZFs. Next option down, we've got location by. So model origin will actually place it relative to where it is in regards to coordinate system. So if it's at X, Y, and Z this, it'll actually place it at that X, Y, and Z. Auto-created base point will actually create that base point somewhere in the model, but it'll place this point cloud right in the middle of your view. So if you're creating a new project, and for those Tekla users out there, they understand that manipulating with models with extreme base points is a little bit difficult when things are out in the middle of nowhere. So auto-created base point would be your one. However, if you've done a scan and you've calibrated that out on site, you're actually able to bring that in through model origin. Then we can set a scale. So once all that's in, we can open up like this, like so. You can see full point cloud. I think this is about 1 or 2 gig worth of point cloud here. And I've just modeled in a structure around that as well. So you can see that once I turn that off, you can see the concrete structure that I've created, and we can do some referencing around that. So something to remember as well, basic modeling techniques such as move, select, undo, rotate, copy, and pop-up menus in regards to the right click isn't available when you're using with point clouds. So once you've got this open, we can't actually move it with our mouse, right? We are able though to move it using the positioning system. So if we've done a measured move, we can actually move this. But 9 times out of 10, if you're working within the project, all this should be in the right coordinate system anyway. Now, we can't delete the point cloud unless we're right clicking and delete there. So detach is really the way to go about that. Another good point is point clouds are not visible in drawings as of yet, and point clouds are not shared when using Tekla model sharing or multi-user mode. They're all local hosted, as a lot of you may be aware. So once we're attaching the point cloud, we've attached it here. We've now got our referencing system here, nice and easy. We can actually modify this in the future, setting our location by, and that's obviously done by this work plane down the bottom. And now we work into our modifying the point cloud and having a look and seeing what we can actually do with it. So if we were to go for something like an elevation, for instance, we can do a quick visual check on if things are constructed the way that they should be. Have windows been cut out? In this case, it has been. These are all internal scans as well, so all the scan data is actually on the inside. So if we just go clip plane, and you'll see that in a second, dragging that across, you can see that all the data that's been captured is on the inside. There's no external data in here. So I believe this was an interior fit out that was once occupied. So if we were to move across, remove that point cloud, or remove that cutting plane, and what we're going to do is focus on this area. So what we can do is isolate that area in the future. So a series of cutting planes here. We can see that there's a series of lights hanging down lights here. There's some switches on the walls. There's a window over here. There's even, I think it's a TX6 case on the ground, nicely placed, as well as another window that hasn't been cut out as well. So I'll show you what it can do when it comes to window cutouts compared to other non-window cutouts. So in regards to visual checking, we can see that a lot of this is aligned with the internal, but that doesn't really give us much of a check. So what we're going to have to do is have a look at the different ways that we can visualize this point cloud. So we can visualize this using this toggle here. We can adjust the thickness of the points, which modifies the amount of points, etc. But this is really just it's called an eye dome. Essentially, it's mainly used for perspectives. So again, gain a higher perspective basically. So the further away it is, it might be lighter. We can turn this on and off. Doesn't look like it's doing too much with this point cloud, but what's really impactful is the points. So we can actually adjust the point size here. Like so. Go back. Thickness actually is changing now, which is good. And we can also change the density. Like so. Down the bottom, if we've got staging of scans, so we can scan an option right at the start. Let's say, classify that as beginning scan. We can move into stage 1, stage 2, stage 3, and then we can overlay all those in the one file. Elevations is something quite cool. We'll set a max elevation to be the top of the roof and the bottom elevation. Now we've got a color-coded system here as to where things are in relation to color. So we've got an elevation chart. Nice and easy. Classifications again. We'll color it by gray or color it by classifications. We can also color these by whatever color we decide. Nice and easy if you're doing a visual check to visually check red against black or red against gray. So that's nice and easy there. But one thing in version 2020, and this is possibly my favorite part of this point cloud process, is that Tekla now do clashes, or what they call as clashes. And what I'll do is just go back to the standard, and I'll just show you what it is out of the box. So what we can do is we can select an object and actually get a tolerance. So we've got saying clashes, but I like to call it QA checks. So we've got modifiable options here. We can change the colors. We can also change the tolerance. We can also change whether things are visible or not. And this is all based off what we select. So if we select the slab, it'll come up with the colors, which is quite cool. All very quick and live. Now, if we want to hide everything further than 200 mil, we can just turn that off, and now we're just seeing what we're selecting. We can do that also for the wall, which is amazing. Wall, and also sidewall with the window opening as well. Now, one of the benefits of this is that as soon as I click out, it actually just goes back to normal. So we can begin to visually check that. So what we're able to do is I've saved away a setting called QA install check, and I've changed my tolerances to be green, yellow, like a light orange if you can call it that, orange and red. And I've hidden everything greater than 50 mil. So anything within 2 millimeters is going to go green or yellow, which is nice. So let's change that to be a light green. Then we'll go to a light yellow. And then we'll go, let's just go orange and then red. So that's nice and easy. Let's change that to be, that'll do. Nice and easy. So what we're able to do now is let's do a check on the slab. So we're able to select the slab and we can see all the high and low points. So anything that's greater than, so if I was to change the colors, so I've gone from full jet orientation there to slight hatching to nothing at all. So if we select the slab, it'll actually just come up and it'll actually say on the underside as well whether they've been to or fro that face. So we can see that we've got some, what's that? So we've got green here, 0 mil, which is fantastic. It actually goes up towards this edge here, and then we can actually identify and isolate those. There's a couple of high points here. A lot of that might be dust, so keep that in mind. But as you can see here, the toolbox, the 50 mil is actually coming up. And we've also got isolation on the walls. So if we were to select away, we can actually see and identify some patches on the ground. So that looks like there's marks on the ground, so there might be something there. But obviously, that's probably within tolerance anyway. So we're pretty good here. Now, if we were to go for the walls, click on the wall. on the brickwork, obviously brickwork is not straight, so we can probably update our tolerances. We might call this QA brick. Save. And go back to here, and let's just go anything within 5 mil, anything within 10 mil, and 20 mil is orange. So now we've got a tolerance check, and I'll just save that QA brick because we'll use this at the other side, is the fact that we can actually save these away as to what our tolerances are. So if we're going through selecting all the steel columns, we just go through, select all the steel columns, QA steel column check, and away we go. Then we've got our tolerances. We know that if it's orange or red, it's obviously bad, but it's also okay because it's got to do a little bit with your drafting license, is what I like to call. So if I go back to the other side, select this one. Obviously we've got a piece of paneling on the wall, some bricks that are out, which is not amazing, not terrible. Might actually be a column along there, so it might actually be a column. Yeah, it looks like a column there. So we've also got some window framing, which we will ignore, and potentially basically some cladding on the internal of the wall that may or may not have been removed. Go back onto the back wall, and we can see that everything down here is greater than 50 mil. Obviously, this is all dependent on where your scan is sat, and basically where you're scanning and where your reference points are. So if I was to move this wall out 2 mil, all these numbers will change again because obviously my model's changed compared to what the real world is. So let's click out of that. We'll go back to QA install check. Could probably rename this as concrete check. Now we can check this here. Now, a good one here is, now that we've got a check based on all this, reporting is just visual at the moment. However, it is something that's being looked at. It's basically, the way it does it is it grabs each point, creates a sphere based on these dimensions here, and gives it a color based on that sphere. So it is referenced to the object, so there is potential there that in the future there may or may not be a way to report that. If you're into API, you may be able to even tap into that as well. So what we'll do is let's start to look at the roof structure. Now we haven't got any roof structure here. Now for this exercise, we're just pretending that we'll pretend that these walls are precast, even though they're not. We'll just leave it. We are a precast contractor. We're not really delving into the steelwork. Now, for the steelwork, let's bring in a model. So I can bring in a model here. I'll just show you what I brought in. So I just brought in this steel beam. Now, because it's a reference model, we can still do this. So if we select the reference model and then go turn on the cloud again, we can see very quickly and easily that we've got some tolerances here. It is very grainy. Only reason for that is that this is, how high is this? This is probably 4 meters high, probably. Elevation. Yeah, about 4 meters high. And where the scanner has been sat is down here. So you may actually, vertically, there may not have actually been a lot of density around there. So if we were to go back and select a beam again, we can then have a look and see what tolerances they are. All well and good. So that's basically let's call that the QA checking based on the point clouds and based on what we can do with the model. Obviously going back and checking this again. Now, if we were to bring in something like a structure, let's say mechanical, we can bring in the mechanical side and use it typically as clashes. So we can say if it's within 10 mil, identify red and turn everything else off. So we can go, okay, we don't care about anything less than 50 or 10. or we don't even care about the good stuff. So we can actually turn all that off and identify solely what is here. Now, the next stage of this is actually how to get this information out to the guys out on site. So obviously a scan is well and good. Now you can possibly do this in the X7 at the moment with the overlaying of the data. But at the same time, you can actually bring in your own layout manager and start creating some points, some example points around these, and by snapping onto the point cloud, and you're able to actually identify these locations using the point manager, export to your total station, and start setting out where these high points are. Cool. So that's pretty much it for working with point clouds in a nutshell. What I'll do now is I will run through the questions that you may have. So I'll just run through. If you've got any questions, feel free to shoot them through into the conversation right now. I'll start running through right now. Chris V, you can see that is this feature planning on coming out in TC? So in TC, the actual this module here was actually, you might have actually noticed this module just here in TC. So Trimble Connect is TC, by the way, for those that don't know. So if you actually have these tools, clashes may be coming. Obviously, it's dependent on the actual model objects that you select. So we're just gonna have to wait and see. That's probably the best way to see it. Hopefully that answers your question, Chris. Cool. Another one. A bit late. What's the easiest way to locate point cloud correctly? So, question is, what's the easiest way to locate the point cloud correctly? Now, locating the point cloud is something that we'll have to look into if you're doing locating point clouds based on an actual survey. So you've actually got coordinates inside the point cloud. That is the best way you can do it. So if we were to attach, model origin is the best way. Now, if you don't have that, that's okay. Auto created base point is basically for use if you're going to be from one end, you've gone from not having a model at all to modeling a point cloud. I'd be using auto created base point because that's going to throw it as close to your modeling window as possible, whilst also maintaining that site-based collaboration or site-based coordination. Now, this point cloud here is basically at 0, 0. Let's go back here. It's basically at 0, 0. As you can see there, the X, Y, and Z axis is actually floating. So we didn't really have to worry about moving this. But if you're georeferencing this inside RealWorks, that's ideal. And then that way you can move it back over into Tekla. If you don't have any site coordination, or if you're wanting to do a calibration based on something that's been built in your warehouse, so a lot of people have actually brought in scanners, scan the actual, let's call it a truss, and truss that's on the fab shop floor, scan that, brought it back into Tekla, and did a quick little visual comparison or seeing basically if that's going to fit on site. So you can actually do the georeferencing manually based off things that are in the model. So it's a two-way process. You can do it reference from the model back out to the point cloud, or you can actually go site coordinates into the point cloud, bring it into the model. So hopefully that answers your question. Best way for that at the moment is actually using the X7. So the X7 is actually the best format because it uses the laser as well as the on-site calibration at the same time. Hopefully that answers, and hopefully we can get it out to you if you've got any questions. Grant, does the clash feature work with multiple E57s or just one E57 file at a time? Tekla is more stable when you turn off the E57s and isolate where you're actually working. Yeah, so I'd be isolating where you're working. So this is where this came in. So if we were to do a test here, I can hit test, and obviously we can modify that around. Now it's only based off one E57. So you can see here that I'm selecting. So if I was to go, I select this E57 here. This brings up all the options. So this brings up the properties, and then I select my object, and then it colorizes based on that. So hopefully that answers your question, Grant. I'd be definitely using the window or a section box to limit your usage. Basically, it runs Tekla a lot easier, as well as if you're using one point cloud, do the class check based on that, and then go back out. Now there is the point cloud manager that I recommend having a look at. That could be a way to basically bring in all your E57s into one file. Hayden, how you going, mate? Hopefully everything's all right over in New Zealand. Can you show how to model from point cloud geometry? I could. Let's see how we can go here. So modeling from point clouds generally, I'll just go back out to here. Generally involves snapping to points. So let's say, for instance, we were to do let's go for something a little bit more complex. 2 seconds. Let's just do this wall here, and we'll just cut out a window. Apologies if this is rusty, but basically we can snap on any point. So what I'll do is actually go to a plan. I'd go to this is a plan view, but let's go a bit of drafting license here, and we're going to actually create a slab. So we can actually create a slab in this face here by selecting points. Now obviously we have to go through and refine these in the future, but essentially that would create a slab based on where that is. Now if we were to go through and go into here, so I'm just going to delete a couple of reference planes. And the entire model. That actually threw it in at the wrong orientation, so that's fantastic. Basically, we just have to bring that forward into the plane. My computer's not handling it amazingly, but essentially it's just a process of tracing. That's probably the best way to explain it. As far as modeling point clouds, you have to really ask yourself the question: if you don't have a model and you're modeling point clouds, how are you using that model? I'm a big believer of not modeling the point cloud itself. So essentially what I would be doing is bringing in the point cloud and modeling around it and modeling my new features around it, because I know exactly what it is right now. I wouldn't be trying to replicate what I already know exists, because a point cloud is there. If there's junctions like I'm connecting up to a wall, I'd model up that wall. That's obviously what I would do and create a connection between the two. I wouldn't go through and modeling all the handrails, but essentially all you're doing is a tracing process. So let's go plan view. And you can just trace around it. The clip planes have been fixed. 2018 version was extremely unstable, multiple model crashes. If you're using 2018, I'd highly recommend using 2020. It's only recently been released, but a lot of fixes from 2018 has been fixed either in 2019, as Chris has mentioned, 2019i, and then also going on to the 2020 side of things as well. So that's essentially 2.5 years. 2.5 years of development has gone into that since 2018. I no longer break down the scans into smaller bite-sized scans. That's a good point actually, because you've got this option up here, show inside work area only. So we can obviously click that, and hopefully I have to redraw. So that's basically chopping it there. If we were to go here, it's this whole work area actually encapsulates all that, and so forth. Sweet, excellent. All right, well that's pretty much brings it to the end. If anyone has any questions, I'll just drop my email address into the below here now. For those that don't have it, a lot of you will most likely have it. But if you've got any questions, contact myself or the Tekla _support at buildingpoint.com.au, and I'll leave both of these in here. For those that are on maintenance, obviously the support line is open. If you're not on maintenance, highly recommend considering it. I know it's tough times at the moment, but the visualization settings are just something that's going to benefit everyone in the long run. So feel free to jump onto that. So that's a couple of the emails. And another question popping up, I think. Cool. Cheers. Awesome. All right. Thanks, guys. Appreciate your time. And hopefully, if you want to have a crack at this, get into 2020. Thanks, mate.